okay? We are unable to hear you, Dana. I'm going to check in with our presenters real quick too. Laura, are you able to speak?
I'm here, Jamie. Can you hear me?
Yep, perfect. And how about Dave?
Yes, I'm here and I can hear you fine.
Okay, perfect. All right, so I'm going to continue going on with our polls then. We have about 8% of you joining us from federal transportation departments, about 12% from state DOTs, about 30% from local transportation departments. We have about 2% of you from tribes, about 6% from public lands agencies, 4% from local technical assistance programs, 13% from other federal, state, or local government agencies, about 4% from universities, 18% from consultants, and about 3% from others that we did not list yet. As far as where everyone is coming from, we have about 13% from the Northeast, 10% from the Southeast, 21% Midwest, 52% Western, and about 3% other. And most of you are joining us by computer only today. There are some of you joining us both computer and phone. I would like to remind you, as always, if you do have any audio issues with today's webinar, our first step would be to have you call in on the phone if you are listening by computer only. The phone number can be found in the top left-hand corner of your screen. I would also remind you that if you do have to call in, please make sure that you mute your computer speakers before you call in, otherwise you will hear some feedback. So I'm going to move us over to our presentation and just go over a few more logistics with everybody. Our duration of the webinar is about an hour and a half. As always, we are recording this and it will be archived on our website within the week. For quality of the recording, we have muted everyone's phone lines for the presentation. Because of this, we would ask you to please put any questions for our presenters that you have into the chat pod on the left-hand side. We will stop today for only one question and answer period. When we do get to that, I will read each of the questions off to our presenters. If you are listening on your phone, as I mentioned, please make sure you mute your computer speakers so that you'll have the best audio for today. For some of the graphs that we will have shown in today's webinar, you may want to see them full screen. In order to do this, in the top right-hand corner, there are 4 arrows that press outward. You can go ahead and click on that button and it will make the presentation itself large and get rid of some of the extraneous information around the outside of your screen. As I mentioned, today we are going to follow a tiny bit of a different format from what we typically do. This webinar has been presented twice already, and so we did not want to have our presenters redo their slides to fit our format. So we will only have one question and answer period today, and it will be at the very end of today's presentation. There is also a handout pod in the bottom left of your screen, and there you can find the PDF version of today's slides in case you would like to download those. We also would ask you to please do the 2 follow-up surveys that you will receive. The first one will come out directly following today's webinar. As always, that is the way that you will ask for certificates of completion and CEUs. Sometimes that email does get caught in junk mail folders because of us using Constant Contact. Due to that, we typically provide you with the survey link as well. The survey link can now be found in the chat pod on the left-hand side, so if you do need to copy that to make sure you have it. The survey will close 2 weeks after the webinar, and you can expect your certificates and the form to apply for CEUs about 4 to 6 weeks after that once we have manually created all of those certificates. The CEU form can be returned to continuing ed at montana.edu and not to the Rural Safety Center. That form is handled by a different department at Montana State University. You can also request a verification of completion form from the continuing ed department, and that will show you all of the CEUs that you have ever received from the Rural Safety Center. Right now on your screen, the top left hand, you'll see the course registration form to receive those CEUs. And on the right-hand corner, you'll see what a verification of completion form looks like. That would provide any of the webinars you've been to with us, any of our in-person trainings that you may have done, as well as our 2 summits that we've done before. The CEUs are provided free of charge to you, and they are reciprocal with PDHs. Today's presenters that we will have are Laura Fay, who is a research scientist at the Western Transportation Institute at Montana State University and the program manager for the Cold Climate Operations and Systems and Infrastructure Longevity and Sustainability Research Group. We also have David Jones as well. He is the Associate Director of the University of California Pavement Research Center at UC Davis, and he also chairs the Transportation Research Board's Standing Committee on Low Volume Roads. Our goal for today's webinar is that once you have completed this webinar, you will have information on converting distressed paved roads to engineering unpaved roads. This will include how to identify a candidate road for unpaving, how to conduct a road investigation, unpaved road design considerations, specific information on converting roads from paved to unpaved, life cycle cost information and tools to aid in communicating unpaving with the public. To achieve these goals, we do have 3 learning outcomes for you. The first is to identify poorly performing paved roads that are candidates for conversion to an unpaved surface. The second is to compare maintenance and surfacing options to make the best decision for your agency. And lastly, to convert a distressed paved road to an engineered unpaved road. Before I do turn this over to our presenters, I will remind you one more time that we will do question and answer period only at the very end. However, you may feel free to put your questions in the chat pod at any time, and when we do stop, I will read those out one at a time to our presenters. So at this point, I would like to turn it over to Laura and Dave.
Okay, good morning, ladies and gentlemen, or it's good morning in California anyway. I'm sure some of you are on the East Coast, so good afternoon to you. Look forward to sharing some information with you today about converting distressed paved roads to engineered unpaved roads. The webinar outline, let me just get used to the arrows here. The webinar essentially is what's in the guide. So it's not a workshop on how to unpave a road. We're not going to be able to get that right in an hour. So what we want to do is share the contents of a guide that we've prepared for the local road research board in Minnesota, and hopefully we'll be able to excite you enough to get hold of that document and consider an unpaving if you have roads that justify that that action. What we're presenting today is essentially a scaled-down version of a 3-hour workshop that we held at the 12th Transportation Research Board International Conference on Low-Volume Roads that was held in Kalispell, Montana in September 2019. The presentation is essentially based on the guide chapters in the same order, so we'll give you a little bit of an introduction to how this all came about. Then we move on to the process of identifying candidate roads. Obviously, not all roads are going to be good candidates for unpaving. We want to make sure that we go through a process there and make good decisions. We'll cover the road investigation because that's collecting our background information and also helps us to make a decision on whether unpaving is a good idea or not. If we are going to embark on this process, then we need to do a design and then go through the process of the actual conversion itself, so a few pointers along those lines. I'll stop talking then and hand over to Laura, who will cover the life cycle costs and the process of dealing with the public, which are all very important steps in the process as well. The whole idea is focusing on upgrading the road, not making it worse. I think the worst thing we can do as agency owners or consultants working for the agency is to take a bad road and make it even worse. We definitely don't want to do that. So the whole idea is to take a bad situation and turn it into something better. And if we can consider this as an upgrading process, then we have achieved our goals in doing that. Okay, so a little bit of introduction to unpaving. As you're probably all well aware, the U.S. road network is pretty large. It's around about 4.1 million miles, and about 1.4 million miles of those are unpaved. And as agencies proceed along the lines of doing conversions back to unpaved, we'll obviously see this number grow in the years to come. Sorry, I just keep missing the arrows here at the bottom. A considerable part of this network, paved network, is rural and generally low volume. Now again, we can get into a big debate about what's considered as a low volume road, but in general we use the OSHTO number of 400 vehicles a day. Like I said, various agencies have various definitions for that. Many of the roads that we're talking about, those roads that are up for consideration for unpaving, were mostly paved in the 1970s and the 1980s, when money was a little bit more readily available than it is today, and asphalt and chip seals were inexpensive. Unfortunately, as things changed, a lot of these lower volume roads have not been sufficiently maintained. And even if they had been, a lot of them are reaching the end of their useful lives, and they now require major rehabilitation or reconstruction. And of course, that's a very expensive operation, and a lot of agencies and counties that manage a low-volume road network just don't have the funds to do this on any kind of large scale. Converting some of these roads back to an engineered unpaved road standard is one option. It can be the least expensive option in the short term, but it's generally not a solution that the public expects or wants. So you might have public that's complaining about the condition of the road, and their idea of a solution is to have it reconstructed or have a major intervention to clear off that old asphalt and put a new asphalt surfacing or chip seal surfacing on the top of it. So getting an unpaved road is certainly not what a lot of people would expect. In terms of the cost or the funding constraints that we have, unpaving is often the only option that we can consider, even if it is in the short term. And if we can get a safer and better ride than the distressed paved road, then it's certainly worth exploring. We can also consider is that if we do a good job of the unpaving, if funds permit at a later date, then we can always use that as the basis for paving that road again and hopefully having a better performing road with that new surfacing than what we had before. We've also got to keep in mind that a lot of these roads back in the 1970s and 1980s were carrying considerably different traffic to what they are carrying now. So if we look in the Midwest, where in our agricultural areas, the agricultural equipment that we're using is significantly larger and heavier and has more wheels, and the trucks that we're using have also grown significantly. So a lot more axles, a lot more wheels, and a lot more weight. So if we want to consider paving those again, we're probably going to have to make some significant structural enhancements to the road to be able to carry the new type of traffic. All right, so where did this all come from? A few years back in 2015, Laura and I put together a synthesis document that was funded by the National Cooperative Highway Research Board program to just get an understanding of where unpaving was. There was a lot of talk about that unpaving was happening, but not very many people knew what was happening out there. Very little had been documented. So we ran a literature review, did a lot of interviews with a lot of people who were considering it or had exactly done it. And out of those discussions came a series of recommendations, one of which was based on all the feedback that we got, was to develop a road conversion design guide or handbook. So some people had some guidance on it because there were success stories, there were failure stories, there was a wide range in the kind of costs that people were reporting on actually undertaking the process. So some guidance was identified as a need to try and streamline the process and make sure we get a good job at the end of the day. The Minnesota Local Road Research Board decided to fund that, and out of that came a guide that is in the process of being finalized right now with Minnesota. We've done our part of it. Minnesota's just putting the final touches to it before they make that public. And all of the information is based on experience developed during conversions in a number of states already. So we're basically put this together on existing knowledge and experience that we've had. All right, the guide includes chapters on identifying candidate roads, doing the road investigation, designing the converted road, running cost analyses, getting the public involved so they're not surprised. One day they have a bad paved road and then the next day they have an unpaved road. Not very many people are happy if they have not been consulted on the process. There are also a bunch of appendices with additional information and guidance and checklists and forms that you can use through that process. So the presentation today is basically going to run through each of these chapters, explain to you what's there, but we're not actually going to show you how to do an actual unpaving operation. Okay, and again, we mustn't lose sight on the fact that the aim is to provide a better level of service than the current distressed paved road at a reasonable cost. That's the whole focus of the guide, and we try and carry that through all the way through. Okay, so the first chapter is doing a little bit of background checking to make sure that your road is a candidate for unpaving. We don't want everybody running out, digging holes in the road, going ahead with a conversion without just running through a simple process to make sure that we are actually on the right track. So a number of factors need to be considered. Is firstly the economics. It's always the big factor. We know we don't have enough money to do full-scale upgrading, and so unpaving is an option that we have to consider, but we've got to make sure that this is not going to be more expensive in the long run. So we've got to factor in the cost of maintaining the road in its current condition or converting it to an unpaved road, perhaps using a chemical treatment and then maintaining it in a good enough condition. So there are obviously costs involved in the longer term maintenance of an unpaved road that need to be factored into that consideration as well. And those costs can include greater costs, putting down chemical treatments for dust control, re-graveling from time to time, etc. The next issue we've got to take into consideration is safety. We obviously don't want to make the road more unsafe than it already is. And we know that severely distressed paved roads are themselves dangerous. So even though they might not have dust or slippery conditions in wet weather, the fact that there are often a lot of large potholes, little patches of gravel, all sorts of kind of basic hazards that people might swerve to avoid, those in themselves are unsafe conditions that we need to take into consideration. But we obviously don't want to make that road less safe than it is now. Traffic is always a factor. We believe that the sort of ideal numbers to get a successful, cost-effective conversion are typically a maximum vehicle per day count of between 100 and 150. A lot of the projects that we've seen to date have typically been in the 50 to 100 range, which is an ideal number. But again, there are a lot of instances out there where we're looking at numbers higher than 150, even if it is as a short-term consideration. But we've got to remember that the higher the traffic count is, the faster that road is going to deteriorate, which increases the maintenance costs along with it. We've got to look at the distresses as well. If they're generally age-related, which is the case with a lot of the roads that we consider, or a lack of maintenance or basic correctable drainage issues, those are generally good candidates for unpaving. But if there's structural issues in there, if people are getting stuck, we're getting very deep ruts in the road, and we're going to have to thicken up that road to be able to make it to carry the traffic, then again, unpaving might not be a consideration because it's going to require quite a lot of material import and shaping and compaction to make sure that those trucks have all-weather possibility, or any other vehicles, for to that matter, using the road, have all-weather possibility. Environmental issues are obviously a concern. Nobody living alongside of the road all of a sudden wants a lot of dust. The dust has a lot of impacts on agricultural activities. It's also unhealthy. If we revert to a gravel surface, we've got to be careful of erosion. We don't want to be polluting nearby streams with excessive amounts of fines that are being washed off the road. And we've also got to factor in that if we don't build it right, or the traffic volumes are higher than anticipated, that we will have to do frequent gravel replacement, which in itself is not necessarily a sustainable practice. Now, most of these concerns, dust, erosion, gravel replacement, can be mitigated by good design, good material choice, good construction, and often chemical treatment programs to keep those fines in place on the road rather than being blown away in the wind and resulting in accelerated deterioration of the road. We also have to consider agency resources. If the agency has a predominantly paved road network and we start moving into increasing lengths of road that are unpaved, then the agency is going to have to do more public relations because we have to deal with the public to make sure that they're on board with doing this and they understand the need to do it. You might need additional skill sets in terms of grader operators. You might need some new equipment as well to do those conversions. Those are often can be put out to contract, but the maintenance themselves are going to require equipment that the agency might not have. So those are also factors that have to be considered. So in the guide, we have a flow chart. I'm not sure that all of you will be able to decipher this on your screens, but it is in the guide. It looks kind of complicated, but it isn't. And it's just a logical process that takes you through step by step. And once you get down to the bottom of the decision process, it's going to tell you whether it's worthwhile to proceed with an investigation for unpaving or whether you should actually re-evaluate your decision and look at another option for the process. So right up at the top, we go into some historical issues about understanding the performance of the road over time. What's happening on the side of the road? Are there going to be people affected by dust, etc.? Some basic cost analyses at this stage to decide whether it's going to be cheaper or more expensive to unpave. Safety issues that might need to be addressed, traffic issues that might need to be addressed. What's causing the distress? Is it aging or is it structural? Are there environmental concerns that you're not necessarily going to be able to deal with? And then how are you going to go about the public, and have they already started being involved in that process? So basically, once you get down to the bottom, if all of your answers take you to that proceed with investigation box, then that's a good place to start. All right, so the next stage is the road investigation. So you've got to get out there and make sure you know what you have so that you can do a design with it. Because ideally, you're going to be wanting to work with the materials that you have in place, but depending on the amount of traffic that you're carrying and what that condition of the road is, you may need to bring in additional materials. And doing this investigation will guide you on what those material choices are needed. So we encourage people to do a good investigation. It's very inexpensive, doesn't take long. Generally, just don't skip this phase. It's going to provide you information on what is out there and why it looks like it does. Two very important considerations for the design that's going to come up after you've done the investigation. It's going to build on what you've already done in terms of that flow chart to decide on whether the road is a good candidate. If you have sufficient materials out there, and if you don't, where you might be able to find them, as well as identifying any problems that might need to be corrected first before you move along with the conversion. And those might be some safety issues, there might be some drainage issues. The costs of doing the investigation are negligible. They're very, very small, but obviously there is a huge factor in there that if you don't do the investigation, you proceed with the unpaving and it doesn't work out because there's some things that you didn't understand, then the costs of going out there and fixing those problems could be significant. It's not difficult either. It might sound complicated as we go through today, but I think the guide is a very simple step-by-step process. So as we say, it's not rocket science, just rocks and a bit of science, and even that science is essentially just common sense. 4 key steps to the investigation. We look at a desktop study, which essentially just gathers some background information. We go out, we walk the road, do a couple of very simple and inexpensive tests on the road. We take a few material samples along the length of the road. We test those. We run some analysis in terms of a simple performance prediction on what those materials are likely to perform like. And then we take our forms that we filled in along the way and kind of stick those together and form a basic report that is going to support our decision of whether to unpave or not to unpave. So the desktop study is really just collecting some relevant information, identifying any fatal flaws before any major effort or expense is incurred. So, you know, doing a bit of background information. If Amazon's going to be building a service center or something like that that's going to bring in a whole lot more vehicles on the road, obviously proceeding with an unpaving is not an option there. It also some basic questions that you can run through to answer. There is a checklist provided in the guide, and basically you can just check off the boxes, and that will take you to the next step again of whether proceeding with the investigation is worthwhile. The information typically that we're looking for is just the history, what kind of maintenance has been done on it, when was it originally paved, what kind of traffic does it take, are there periods when weather issues have a big effect, like freeze-thaw cycles perhaps, major rainfall events when the road is impassable. Are there any safety considerations that have already been brought up to your attention, either because of the distressed paved surface or potentially some geometric issues that might need to be considered. Then there are also perhaps some other factors that you might take into consideration there as well. Then once you get out there on the road, what are we looking at? Well, basically just simply walking the road or driving the road very slowly, riding it on a bicycle, whatever. Remember that driving along the road at 30 or 40 miles an hour, you might miss a lot of things, so we certainly encourage walking it. You're going to want to document your observations. Again, there's a bunch of checklists and forms in the guide provided to help you along those ways. We want to be identifying the reasons and causes of distress and identify representative areas where we can check the thicknesses of the materials that we have or out there already, and to take some samples to do some simple laboratory tests. We also encourage people to take photographs, and so that can help you sort of jog your memory about some of the things that you were looking at. The next thing we want to do is do some simple dynamic cone penetrometer tests. If you don't know what a dynamic cone penetrometer is, I encourage you to Google it. I will show you a photograph in the next coming slides, but this is a very simple, very useful tool for understanding the material properties that you have there, and also very importantly to identify the layer thicknesses and to get an understanding of how good your materials are below the road and whether they're likely to give you some problems. We're also going to use that information to decide on how thick the new road has to be in order to make sure we can get all-weather passability. We want to be checking layer thicknesses, both with this dynamic cone penetrometer and then also to dig a couple of small holes in the road to validate what we've discovered with the dynamic cone penetrometer. We want to sample some representative materials, as I said, for doing some basic tests. We want to test those materials. We need to interpret the results in terms of how are these likely to perform under a given set of conditions. And then, so that's the overview, sorry. And then our first step, as I said, was walking along the road. As I said, there's also a checklist in the guide that we follow along. We want to be checking for general problems. We want to get an understanding of the causes of distress. Again, remember, age-related distresses are fine, good ideas for unpaving, but if we've got major structural issues or major drainage issues, we are going to need to correct those before we proceed with the unpaving. We want to get an idea of variability along the way there in terms of materials and layer thicknesses, because if it's a long project, we might want to have a couple of different design scenarios to make sure that we take care of that variability. We want to get an understanding of the materials both on the surface and below the surface, everything that we're going to be able to work with while we're doing this unpaving process. We want to take a look at drainage. Very important to make sure that when we have an unpaved road that we can get water away from off the road as quickly as possible and then away from the road. We don't want a lot of ponded water right next to the side of the road that's going to keep that road soft. We've got to look at safety and roadside activity, any other pertinent issues that are out there, and then obviously to identify representative sampling areas where we can get good materials to run our tests on. The guide provides details and a lot of photographic examples for each of these areas of interest. So once the guide comes out, you'll be able to look at that, basically explaining why they are important and what you need to look for. Next step is identifying the testing and sampling locations. So where do we want to run these dynamic cone penetrometer tests, or DCP tests as we call them? Run some layer thickness checks. That's going to be a small hole in the road, and then the material sampling locations, a bigger hole in the road. And again, the guide will give you dimensions on how big those holes need to be. The frequency of doing all of these things is going to depend on the project length and the variability. If the road is not variable, then we probably just do 2 locations at the beginning and the end of the project. If it is more variable, then we need to use the dynamic cone penetrometer to identify that variability and then choose representative sites within those common areas. So we use the DCP, and again, I'm going to try and call up a pointer here. Okay, there we go. So basically, it's a top rod, a bottom rod, a weight that we just pull up to the top and we let go, and then a ruler on the side here, and we just measure the rate of penetration through the layer into the subgrade. And basically, the better our materials are, the slower this is going to go through, and the worse the materials or the wetter the materials, the faster it's going to go through. And we can use that information to tell us about, let me just turn this off, there we go, to check for layer thicknesses, to check for our subgrade shear strength properties. We can get a California bearing ratio number out of that rate of penetration. We can see whether there are moisture-related problems. So is it very soft down there? Is it very wet down there? Do we have drainage problems? We can use it to identify uniform sections, so to pick out that variability. And then we can also use it to identify material sampling locations as well. We take those material samples to check the material properties and then to predict likely performance. Remember, we're going to try and work with all of the materials that we have on the road, so we need to know what's down there and how we're going to mix all those. What are the properties of those mixed up materials going to look at? How deep do we need to go when we're mixing those materials? And if we need to bring in additional materials, how much are we going to need to put on the top to give us a good performing road? So the laboratory testing is also important. I know a lot of people like to skip this phase because they think it's expensive, but we're only looking for a couple of $100 of tests that needed to be done, and that information can tell us a whole lot about how the road is going to perform. We need to collect materials from each of the layers, including the underlying subgrade. And if we think we're going to need supplemental material, it's a good idea to go and get that material and run the tests on it at the same time because we're going to use the properties in our design phase to make sure that we come up with a good material that's going to perform really well out on the road. If you're going to incorporate that existing asphalt material into the surface, it's quite okay to do that, but obviously it's very difficult when you're doing your sampling to get a representative sample of that material once it has been ripped up by the grader or milled up by a recycling machine. So the guide does include some material properties that are typical of what will come out behind a recycling machine. The tests that we're looking to run are a grading analysis. So really what we're interested in finding out there is the ratio between the fine, intermediate-sized particles and the large particles, because we need to get a good ratio, good balance between those three different groups of sizes to make sure that we get a good structure, no air voids or high air voids. We can get a good compacted material that's not going to allow any water in and that's going to hold itself together when subjected to traffic. We need to know a little bit about the clay. We're going to rely on the clay to hold the road together. Too little is going to result in the road washboarding, like the photograph that you see on the top right-hand side of the slide there. If we have too much clay in the road, we're going to get impassability problems and slipperiness when it's wet. So we need to know how much clay is in there. We need to make sure we have a good balance. If all-weather passability is a major concern on this road in high rainfall areas, for example, then we might want to do a California bearing ratio test on some of those materials as well, but not always necessarily. We can often get that information just from our dynamic cone penetrometer results. If you have internal specifications that you want to abide by, you might want to be checking that against those specifications. But in the guide, we encourage the use of a performance prediction chart just to give you a basic idea of how those materials are going to perform. So this chart looks something like this. The black writing is essentially what's on the chart, and the green writing gives you an indication of what you need to do to get it into a better performing material. Let me just call up the arrow again. So on our left-hand side here is basically our clay properties from our plasticity tests, and along the bottom here we have our ratio between our fine, intermediate, and coarse particles. And basically what it does is uses those results to plot the likely performance of the material. Let me just turn this arrow off again. Okay, so the first situation that we might have, as is shown on the photograph on the top side there, is basically materials that has too much clay in it, so that's going to give slippery and impassable conditions. Down the bottom here, we don't have enough clay holding the material together, so the traffic's going to cause washboarding and raveling. We don't want that to happen, so we want to make sure we get an optimal clay mix. On the left-hand side, we have materials that's generally very fine, potentially with some gap in it, so it's not being held together, and erosion is going to be the consequence. We don't want that to happen. And then finally, materials that are gap graded or tend to have more coarse than fine are going to ravel. You can see there's a lot of loose stones on the surface there. We don't want that to happen. So the whole idea is to get a good blend of materials that's going to plot in that really good box, and then that will take care of most of the situations that we have, give us a good performing road that is not going to require a significant amount of maintenance, and the gravel is going to stay in place for as long as possible. Next, we move on to our dynamic cone penetrometer analysis. And again, this is just a simple plot of the penetration versus the number of blows. As we can see here, again, from the, let me just give you a, whoops, we're missing something here. Let me just show you with the arrow here. Again, so here you can see basically a sort of divergence where suddenly the rate of penetration increases. So this is basically telling us that we have about 12 inches of good material and then down into the subgrade, which in this instance is still pretty reasonable, but obviously a little weaker or perhaps a little wetter. So in this instance here, we can see it took us about 40 blows to get through to 12 inches. Further along the road, you can see a little bit of variability. Here we have about 75 blows taking us through to 12 inches. If we move on to the next table, which is also in the guide, it basically tells us in terms of our millimeters per blow through the pavement that it gives us an approximate California bearing ratio range and then how that material is likely to perform. So again, with our example here, on the first example was down here around about the 8 to 14 range, which is telling us that of the first part of the road that we've got generally good performance, and then the latter three measurements that we had were in this area up here, which is telling us that we've basically got some good material underneath that failing asphalt surface. So that's information that's telling us that we've probably got good materials on the road that we can use, and we don't necessarily need to bring any additional materials in. So that basically wraps up the investigation. We want to basically just put all of that together. So the ideal is we don't want you to go out and spend lots of time writing a detailed report. You're obviously welcome to do that. But pretty much we formulated the checklists and the forms together that if you basically stick all of those together, it will have a decision at the end of the time, and you can just use that as your report. The key issues that you might need to note here is, first of all, do we have enough material out there to do this recycle, or are we going to have to bring in some additional materials? Because that's going to have a cost implication. You're also going to have to find those materials. Are there any subgrade concerns? So do we have weak spots that could become a problem either during freeze-thaw processes or if we have some very high rainfall events and we're running trucks on that road? Do we need to correct some drainage issues? It's often a problem out there, but it's usually a quick fix. Just to put out some good side drains there, get the water away from the road as quickly as we can, maybe incorporate some culverts or something like that, some cross pipes. Any underground services that we need to worry about? Again, if we're going to be mixing up materials from underlying layers, we don't want to be hitting any gas lines or water lines or electrical cables down there. Any safety issues that we might need to pay particular attention to, especially if it's going to be an unpaved road. Might be a little bit more dusty, might be subjected to slippery conditions during excessive rainfall, speed issues, anything like that. And then any other perhaps fatal flaws after that investigation that's going to tell us, unpaving is not really an option that we need to consider. Our next step now, if we're going to proceed with it, is to actually design this unpaved road to make sure that it is going to be better than our existing distressed paved road. The first thing with the guide is really based on the fact that we're going to do an active conversion. Politically, some agencies prefer to go down the passive conversion, especially if they can't get the public on board. So passive conversion is where you basically just let it eventually become an unpaved road on its own. We don't advocate for this process in the guide. You do get a lot of safety issues along the road with potholes that are difficult to maintain, chunks of the old surfacing flying out, perhaps breaking windshields. A lot of them might have material properties there that are difficult to maintain as the road reverts to an unpaved road. The photograph up on the top there shows a little patch of paving in the middle, and then washboarding on the other side. So very difficult to maintain that with a grader, to keep it level and safe and give a good ride. So the rest of the guide is essentially based on doing an active conversion. The whole idea is, as I mentioned before, is to ensure that the converted road is going to be better and safer than the distressed paved road. So that's the focus of the design. We want to make sure that we're providing a safe all-weather passability. And since the dust is usually a significant concern raised by anybody living next to the road or driving on the road, we might want to be considering chemical treatments as an integral part of the design and the conversion and the maintenance program. Chemical treatments are not only going to reduce the dust, we've got to remember that dust is actually fines that we are losing from the road, and it is the fines that are holding that road together. So if we can keep the fines in place, then that's going to reduce the amount of times that we need to come back and blade the road. It's also going to reduce our rate of gravel loss. So at the end of the day, we usually find that a good chemical treatment application is going to reduce the cost of the maintenance, and the cost of the chemical treatment are paid for by the lower numbers of maintenance interventions that we have to take. So what are we going to be considering during this design process? The first thing we need to look at is thickness, to make sure that the trucks and the agricultural equipment and the cars that are using that road are going to have all-weather possibility. They're not going to get stuck in the mud when it rains. The next part is the materials, to make sure what is our optimal blend of our existing materials, and if we have to bring in additional materials, how much do we need, how thick are we going to spread it on the top of the road in order to do that mix. We need to factor in drainage. We need to, if we're going to use a chemical treatment selection, we need to choose the right one for the conditions that we have. We need to factor in any safety considerations that we're going to have to take. Are we going to have to put up new signs, for instance? Are we going to have to warn the public more to slow down, that there's sharp curves coming up, etc.? And then finally to come up with a plan and specifications that whoever is going to do this conversion knows what is required and what they're going to need to produce at the end of the day. Thickness design, we just use a simple table. Traffic on the left-hand side, our California bearing ratio, which we've calculated from using the table that I showed you previously, in terms of our bearing capacity, and then on the right is the suggested minimum gravel thickness that is going to be required to ensure that we get all-weather possibility for that traffic volume and subgrade shear strength. This is a table that is taken from the Federal Highways Unpaved Road Design Guide. We haven't changed it in any way. And you can simply see here, for example, that if you have around about 50 trucks on that day, average, and you've got a typical average subgrade conditions, you're going to need about 12 inches of material on top of that subgrade to make sure that you have all-weather possibility and you're not going to get deep ruts when it rains. Moving on to the material design, we've got to optimize the properties of our wearing course layer to reduce the maintenance and the regraveling frequencies. We don't want washboarding, we don't want erosion, we don't want any slippery conditions. We certainly don't want vehicles ending up like we show on the on that photograph on the top right-hand side. We obviously need to meet our agency specifications, but more important, we want to make sure that we get optimal performance out of that material at the end of the day. We have 5 likely scenarios that are covered in the guide in terms of how we handle our materials. The first is just removing the surface and using the underlying layer as the new wearing course. Pretty simple to do a design on that. Our second option is to look at bringing in supplemental material, spreading it on top of the existing surface, and just using that material to serve as a new wearing course. So we're not going to mix it in with the underlying layers. We're just going to build new gravel on top of that existing road and move from there. So we're not going to change anything underneath that. Third option, or third scenario that we're considering, is we're going to remove the surface, and then we're going to mix up the underlying material, so that old base course, if there was one there, a little bit of our subgrade, perhaps to bring up some fines or to bring up some clay, to create a new wearing course. And that old surfacing material is taken away, crushed, used somewhere else, stuck on a wrap pile for new asphalt, something along those lines, but we're not going to use it in the new road itself. The fourth scenario that we cover in the guide is looking at using all materials. So we bring in a recycler or a grader or a crusher, whatever, and mix in all of the materials that we have in place to form a new wearing course. That's probably going to be the most common scenario out there that most people are going to face. And then finally, if our materials that are in place are not sufficient or we don't have enough of them, then the idea is to bring in some supplemental material, spread that on the surface, and then recycle all of that together to give us our new wearing courses. So 4 and 5 are going to require probably the most design input into the operation. In terms of doing this material design, if you're ambitious and you like a little bit of a challenge, you can do it manually. There's a whole process included in the guide, and basically you run through the steps on this form, and you will be able to come up with a theoretical ratio between your different materials that you have out there and come up with a single material that you can run the calculations on and plot those results on the chart at the bottom of the corner. Again, remember, it's only a theoretical process, so you are going to have to take that theoretical blend, run a new series of tests on it to make sure that you're coming up with the right material. Now, if you're not that ambitious, we have a tool that will basically do all of the work for you. The website is showing up there. I am going to warn you right now that it is down. There are a couple of bugs that we are correcting, but it should be up in the next couple of weeks, and you'll be able to run through the process there. I'll just show you a screenshot of that. That's basically the introduction part to it, and then this is the actual chart itself. And just bring you the arrow there and show you a couple of things here. So basically up on the top here, you put in your road information. Down at the bottom here, you put in all of your existing materials from your laboratory test results from your different layers. And if you're going to bring in supplemental material as well, you can put that information in there. Up on the top here is your design thickness that you need to make sure that you get all-weather possibility. And then your depth of recycling is kind of an idea of how deep you think you are going to want to recycle to achieve this thickness design, and again, in terms of the materials that you have out there. Down here, you can add supplemental materials if you want to, and then once you click on the Proceed button, it will give you your information here in the table at the top there, and then plot where that material is going to end up. Down at the bottom here, you can actually test your theoretical blend and check, again, that will plot here to see if you're in that good block or whether you're out. And you can keep basically running through a couple of tweaks here to carry on until you get to that good block. Again, retest that material to fit in. So it's a very simple material design process that you can follow, and the idea is to use this prediction chart to make sure that you have a good quality material. Moving on to drainage, again, we want to make sure that we can get the water off of the road as quickly as possible, and then to take the water away from the side of the road to make sure it's not ponding there. The existing road, because it was a paved surface, probably has a crown of around about 2%. That's typical for paved roads. We've got to remember with an unpaved road, it's a little bit rougher, so it takes a little bit longer for the water to get off. So we certainly don't want ponding. The photograph on the right-hand side shows a typical 2% crossfall, and we tend to get water ponding in the middle, which causes potholes down the middle of the road. We definitely don't want that. So we encourage people to use a crown of about 4 to 5% to make sure that we can get the water off as quickly as possible. We don't want to go higher than 5% because if you're driving a truck and a trailer down that road, it's going to be a little bit more difficult to control because the trailer is going to want to move more towards the side of the road. Again, there's a lot of guidance and existing guidelines out there as well. We encourage anybody doing an unpaved road design to use the guidance provided in the Federal Highways Unpaved Road Design Guide, and there are also U.S. Forest Service guides on unpaved road design and construction that also provide a lot of very useful information. The next step is to decide if we're going to use a chemical treatment selection, is what kind of chemical treatment are we going to use. There is a separate guide that's available on our University of California Pavement Research Center. There is a link to it. You can download that off of the website free of charge, no problems at all. And there's also a tool, another tool out there on the web. Follow that link and it'll take you there to help you choose the right chemical treatment for your road. And again, that's a screenshot of what the introduction to the guide looks like, and then here's the tool. So again, on the, here's my arrow here. Again, you can plug in the results of your blend, your material blend that you're going to come up with. That will plot where it's going to perform. So we're showing here, it's in the good block here. This is your basic objective of what you want to achieve in terms of long-term fines presentation, all-weather possibility. Choose one of those objectives. We put in our traffic data, we put in our climate data. We can also add if there's more than 10% trucks, if we have steep grades on the road, if we have sharp curves that we need to be dealing with. And basically here is that once we put in all of this information here, on the chart here, it will basically give us a ranking of which are the best types of chemical treatment to use for those given situations there. Anything in orange here is basically a warning. It's not telling you that you can't use that chemical treatment, but it's just a warning to tell you that one of your input parameters, either the material or the traffic or the climate within the number of trucks, is going to be a concern in terms of the likely performance of that materials, and you might want to address that. And again, you can make changes, tweak the materials, change your objective, tweak the amount of traffic to make sure that you have the right kind of treatment. There is also links to where you can get these types of chemical treatments. We don't endorse anything on the site, but again, some guidance on where you can find those chemical treatments. Safety considerations, obviously very important. We need to, any of the safety concerns that we've identified during our investigation, how are we going to factor those into the design? A lot of the road surface related issues like washboarding, loose material, slipperiness, will be taken into consideration if we do a good thickness design and we do a good material design. So a lot of those issues will be taken care of. If dust is a major concern, then we need to choose the right chemical treatment. So again, dust will be taken, dust factors will be considered by using an appropriate chemical treatment. And then any other concerns that are out there can often be addressed with appropriate road furniture. So we might want to stick up a few more signs, warning people of sharp curves, warning people of loose gravel perhaps, temporary ponding of water, speed restrictions, suggested speeds, intersections coming up, anything like that might be important there, where we can throw in a few more signs, not a significant increase in the costs, but certainly will improve the safety considerably. And where necessary, any road safety plans that you have for those roads, you will obviously need to update them because we're going to have a change in surface. And as we said, we are actually striving to make that engineered unpaved road safer than the existing distressed paved road. And then finally, in this part of the program is to put together a conversion plan. So this is basically just guidance on what you're going to be doing. If you're going to be bringing in supplemental materials, how thick do you need to spread them? How deep are you going to mix materials down to? Where you're going to put your safety signs? What actions you're going to take? How you're going to handle traffic while you're doing the conversion process, etc. So just a basic plan that you're going to put together. Again, there is guidance in the guide on how to do that. Specifications, obviously each agency has its own specifications. If you don't have a good specification to go through the process, there are example specification language provided in the chemical treatment selection guide, and you can cut and paste out of those selections to suit your particular needs. We do encourage people to follow the specifications and to enforce them. Your road is only going to be as good as what you inspect and verify from the contractor that's working out there. Okay, and then finally, the last part of my presentation, we'll run through this pretty quickly, is the guide just covers some basic information about how to do a good conversion, some guidance on what kind of equipment you use, just bringing in those materials, importing them, spreading them to the right thickness, making sure we don't get segregation and those sorts of things, the actual recycling and mixing process, the compaction and shaping process are all very important to make sure that we get good performance out of the roads, how to apply the chemical treatments, and then how to maintain the road once you've done that conversion to make sure that we keep it in a good condition, don't let it deteriorate to the point that it becomes unsafe and undrivable. Some key issues that are covered, keeping in mind that unpaved road, it's essentially an unpaved road construction that you're going to do, And there's a lot of guidance in the federal highways, and the Chemical Treatment Selection Guide, the U.S. Forest Service. There's a lot of information that we refer you to make sure that you do a good job of it. We encourage people to look for opportunities to correct minor issues, geometric issues, safety issues where feasible, maybe make a sharp corner less severe, maybe take out a couple of serious humps so we don't have such a roller coaster ride, things like that. Guidance on enforcing specifications, doing quality control and quality assurance, and then taking obviously all the necessary safety precautions while you're doing the conversion to make sure that we don't have any incidents on the road that could cause some injuries. And that's about all I have to say, so I'm going to hand over to Laura now. I encourage you to unmute your phone, Laura, and take over. That's all I have to say on my part of the guide. Thank you.
Thank you, Dave. This is Laura. I just want to get confirmation that you can hear me.
Yep, we can hear you great.
Great. Okay, so thank you, Dave, for covering the bulk of that. At this point in time, I'm going to go over the last two sections of the guidebook, which provide tools for you for life cycle cost analysis and communicating with the public. So what we've found is that, I went a little too far, I'm going to go back. Conducting a life cycle cost analysis can be one of your initial tools that can help you determine if your road is a candidate in the long run. One of the main reasons identified for unpaving was lack of funding for continued maintenance. And you can see in the picture in the top right just kind of the patchwork of repairs that's gone on some of the roads that we have out there. And so we're going to present some tools that are out there that you can use to help make this decision. All right, so generally speaking, on higher volume roads, it is more cost effective to resurface with an asphalt or a concrete layer. But as Dave mentioned, typically in that 150 vehicles per day or less, what we've found is that it is a cheaper option to convert to an unpaved road. Now that cheaper option does not necessarily consider the long-term maintenance costs. So part of what we're showing you are only tools that consider the long-term maintenance costs that would go into maintaining an unpaved road, which is critical for this project. One thing we did as a part of the synthesis project and then also with this guide was we reached out and we asked folks, if you've done an unpaving project, what did it cost you? And the price range was, it was huge, frankly. But on average, people spent around $6,600 per mile to unpave a road. Now keep in mind that while this number is significantly lower than putting on a new asphalt layer, it's important to note that this doesn't paint the whole picture. These are values that people provided and they weren't necessarily able to say, yes, this folds in 5 years of maintenance cost, or the equipment we had on hand and so we didn't fold in the cost of that equipment, or the folks that were doing the road conversion, they billed their hours to a different account, so we don't have the person hours included in this. So part of the life cycle cost process in the guide provides you with a framework so that you can track your costs and look at every single cost piece from the person hours, the equipment, the extra material, the change in practice for maintenance over time. That's all critical information that we're hoping that you guys can capture and consider. So the first tool that I'm going to talk about here in this presentation is the Local Road Surface Selection Tool developed by North Dakota State University in their LTAP Center. You can see a screenshot of what the tool looks like, and there is a link to it. It is active right now, and you can go in and use it. The tool was based on information from 3 separate states. So as you go in, you'll see that some states have some baseline data already entered. Minnesota happens to be one of them. If your state is not within that baseline data, it's okay. You can enter in all of your own data to make it work for your road network. And what's great about this tool is you can see all the information that's needed in those bullets. You can come to this tool with all of the information that you've captured from your background research on that road segment and enter that and get a fairly accurate cost estimate for that road segment. So try to be as accurate as you can with your information so you get a more realistic result. There's a few pieces of information like the discount rate percent that you can read about, but essentially it has to do with how much of the material can you reuse or sell off and recycle, such as a recycled asphalt. But it does consider everything, including cost of additional materials, frequency of maintenance, and then you can look at the long-term life cycle costs in 5-year increments up to 20 years out. So you could essentially, for your road segment, play with the different materials that you came up with in your initial analysis that Dave just showed. And you could put those in, and you could look at your life cycle cost at 5 years, 10 years, 20 years. And this could be a tool that you then print out, and you either share this with the public, you share this with your supervisors and staff, or even communicating with politicians or your commissioners. And the folks that maintain this website are very responsive, so if you have any questions, feel free to reach out to them. There are quite a few other life cycle cost tools that are out there, and they're presented in the guide. This one happened to be the most robust for dealing with the unpaving projects, and that's why we highlighted it here in this webinar. So moving forward, this is the last portion of this presentation and the last chapter of the guide. And communicating about unpaving can make or break your project, frankly. If you do a Google search for unpaving or reversion projects, what you find are a lot of negative media articles. And when we did the synthesis report, there was a lot of concern. People did not want to talk about conversions that they had done, and they didn't want their name or their county necessarily associated with this report. And so what we identified were some folks that communicated well, not necessarily received only positive feedback, but accepted the feedback and moved forward with it. So some tools that we developed to help support you include how to communicate with the public and politicians. And what we encourage is just openness and clarity with folks that may be impacted by an unpaving project. And this may serve as a letter that is sent out to landowners and road users, identifying what the options are. This allows them to feel a part of the process, and hopefully you can ask them for their input, and so they feel like they're a part of the solution. What's been found is that when you do bring landowners and road users to the table, it has helped in identifying creative solutions, such as cost share programs, especially once people understand the financial aspect of why a road is a candidate. When you present the numbers to, let's say, a public forum of people about why roads are candidates for unpaving, and you show the cost of repaving and fixing the road versus the cost of unpaving, those are tangible numbers that people can understand, especially if you're trying to show that against maybe what your county budget is, and how usually there just isn't enough money for even paving one road, let alone multiple roads in a county. Another piece of information that we captured from others was consider having a point person at your agency to receive this feedback and serve as kind of the point source for providing information, or the public face for this project. So you may already have an HR person at your office, or you may have kind of a media savvy person, this would be the right person to choose. And essentially on your website or in any letters or press releases, their name and contact information would be provided. And then you, as the person leading this project, would provide them with all the technical information so that they can provide answers and more accurately receive feedback from the public. So we provided this very simple flow chart for you as you're going through this process. Really just to make suggestions and provide guidance on different ways you can communicate at the different steps in the process. So let's say you have identified 4 road segments that you are considering unpaving. So some suggested communication along that line would be for road users and landowners impacted by this decision or this potential decision, send them a letter, send them an email, letting them know about this segment being identified as a potential candidate and providing information on where they can provide feedback, whether that's a public or town hall meeting or whether through a media release or a press release, they can provide feedback over the phone or via email through your website. Let's say you've gone through this, you've received feedback from folks, you've taken in their considerations, and you do have one road segment that is scheduled for unpaving. At this point, we suggest and highly recommend that for anyone living on the road or say a business or person that needs to utilize the road to access the larger road network, that they receive a letter directly from your agency letting them know what the unpaving process is, the schedule of activities, and what they can expect, how long the road might be under construction. Also, potentially informing the media of a road construction project in that area could be helpful for folks. Now, in addition to all of this, we've also provided templates for all of these ways to communicate. So in the guidebook, in the appendices, there is a template letter that you can enter in your own information to and use to craft a letter to send out. There's also a template for a press release, as well as a template for a presentation that you could use at a public or town hall meeting. So there are many ways to communicate in this day and age, and while I say a letter, you know, I live in rural Montana, and a lot of us still like to get snail mail, and a lot of older folks don't necessarily have email yet. So while email may be the most efficient way, consider also sending a letter. But to make it easier on your agency, you may also want to post information on your website or on your social media site. And those are things that you can discuss at your agency and determine what's most appropriate for you. Again, you can use town hall meetings to communicate and receive feedback. We've also developed a fact sheet. So it's a 2-page fact sheet. You can see a screenshot here of the front page. It's a front and a back. And it essentially just provides very simple language explanation of what is unpaving, why would a road even be considered for unpaving, and then you can add your information on the back of any specific locations and contacts so they can reach out to you. And again, as I mentioned, there's also example press releases that can be used. So at this point in time, I'm going to hand it over to Jamie, and I believe it's time for Q&A.
Perfect. Thank you so much, both Laura and Dave. At this time, we will take any questions that you may have over in the left-hand side on the chat pod. And while we are waiting to see if some questions come in for our presenters, we also have a few questions for all of you in the audience. So our first question for you is, which of the following are factors to consider when identifying paved roads as candidates for conversion? Is it history of the road, traffic, weather issues, safety considerations, all of the above, none of the above, or I don't know, I don't remember? Our next question is, true or false, you should compare maintenance and surfacing options to make the best decision for your agency. The third one is, when converting a distressed paved road to an engineered unpaved road, the following must be considered. Is it thickness design, material design, drainage design, chemical treatment selection, safety considerations, conversion plans and specifications, communication with the public, all of the above, none of the above, or I don't know, I don't remember. And lastly, one of the things we've been doing in all of our webinars lately for the Rural Safety Center is to challenge everyone to come up with at least one action item that you'd consider implementing in your jurisdiction based on today's webinar. So that very last poll question is an open answer pod, if you'd be willing to share with us what some action items might be based on today's webinar that you can take back to your own jurisdiction. And again, we'll give you just a few seconds to go ahead and fill out all these poll questions. And lastly, the chat pod over on the left-hand side is where you can put any questions you may have for our presenters. This, again, will be the only time to ask questions. Okay, so Laura, I'm going to go ahead and end the first poll and broadcast those results so you can see them, and I'll continue ending and broadcasting as you address each one.
Okay, so I'm going to let Dave take this first question, which is from Stacy, and it says, do you have any experience or comments regarding the use of ground recycled asphalt tear-off shingles in unpaved roadway design?
I don't have a lot of experience. Thanks, Laura. I don't have a lot of experience in using shingles. But we do know from trying to put them into hot mix asphalt that they should not be too much of a problem. If you ground them up, they're generally going to be very fine because there isn't any coarse material in a shingle. So if you needed supplemental fines or you needed some finer material down to the bottom there, obviously it doesn't have any clay in it, then no harm in using it. It's very unlikely that any of that asphalt would activate and start sticking together certainly in the short term. So yes, you can use them if they're ground up. Obviously you don't want a shingle sized piece of material in the road without having been broken up first. That's obviously not going to work well, but if they're ground up, then you can use them if you need supplemental materials.
Perfect. Thank you very much. As for our poll questions that are coming in, for the challenge question, it looks like we have several action items that people are considering. So they include more lab testing before an unpaved candidate is considered, the cost of maintenance. Someone is asking when the guide is going to be published. So Laura, I'll let you take that answer.
Yeah, thank you. So it's been a long process in the final revisions, and we're hoping that in the next 2 weeks it will be posted to the MnDOT LRRB website. I've already spoken with Jamie, and what we will do is as soon as the website is posted, we'll definitely have a link up on and available, but we will also email to everyone that participated in any of the webinars as well as the workshop that we did at the Low Volume Roads Conference. You'll all get a link to the guide so you can go straight to accessing it.
Perfect. And I've closed out and broadcast the results for the other 3 poll questions. Would you mind going ahead and talking about whether or not the audience got the questions right or not?
Sure. So the first question regarding which of the following are factors to consider when identifying paved roads as candidates for conversion. 91% of you said all of the above, and that's correct. While some specific issues may play a greater role in your area, considering or at least thinking through all of them is highly recommended. The next poll question was true or false, you should compare maintenance and surfacing options to make the best decision for your agency. Congratulations, everyone, 100% correct. And the last question was, when converting a distressed paved road to an engineered unpaved road, the following must be considered. And a lot of folks indicated material design. Well, no, one person responded and they indicated material design. I guess a lot of other folks did not take that poll, and that's fine. For this answer, again, pretty much all of the above. We are really hoping that you consider, at least think through the information in each chapter to make the best informed decision for your road.
Perfect, thank you. And we do have a few other questions coming in for you guys from the chat pod. So the next one is, did you say that this process can be done for $6,600 per mile?
So yes, that was the average cost that we identified from people that had cost information for us. But there's a huge caveat associated with that, in that we do not know if the long-term maintenance costs were considered in that. We believe it was just the initial cost of unpaving the road. And on that same note, not everyone was able to say that yes, equipment, person hours, additional material costs were considered in that. So the number may be a little low, but if you go into the final report for the unpaving project when it's posted and the NCHRP synthesis, you can find the cost information that was reported by each individual person, and you'll see that the cost range actually varied from $1,000 up to in the tens of thousands of dollars.
Perfect. And we did have you guys talk to us about that NCHRP project previously, so that webinar is also posted on the Safety Center's archived webpage. I will post that in the chat pod here after I ask the next question. And the next question that came in was, please share your experience with winter maintenance on unpaved roads, for example, snowplows and the longevity of unpaved roads.
Dave, do you want me to take this? I'm actually
you're the winter maintenance person. I can add on to it if necessary, yeah.
Okay. So we did not really cover that at all in this guide. From my experience with winter maintenance, drainage is always most important. Usually the gravel surface works well in winter because you have more friction. But again, you want to be careful, and you don't want your plow blade to be ripping that gravel surface off. So you kind of want to float your plow blade above the road. Other than that, there's not a comprehensive guidance book on plowing on unpaved roads. It's something that's come up at the TRB, at the national and international level quite a bit. But there has not been a ton of support for it. So if that's something that's important to you, please let us know, and I'm happy to take that to the table as a need.
Yeah, I'd just like to add is that, yeah, obviously you have to be careful, but it's probably no more difficult to maintain a good unpaved road as opposed to trying to get snow off of a distressed paved road, because obviously your blade, whatever you're using to do that maintenance, is going to rip up a distressed paved road and pull chunks out of it. Obviously we just need good snowplow operators that are not going to take too much of the surface material off. Do you want me to handle the question from Robert?
Sure.
Okay, so the question is, if people live along the converted road, they will probably complain about the increased dust. That's their experience. Even with dust control chemicals, it can be hard to control the dust to folks' satisfaction. Yeah, I think it's always difficult to keep all of the people happy all of the time. But again, we encourage the use of the chemical treatment selection guide, that if you choose the right chemical, obviously if you have a good starting point with your materials and you do the road design correctly, we do find that a lot of these chemical treatments will give you at least a sort of a 90 to 100% dust reduction along the length of the road. So again, it can just be choice of chemical treatment, certainly the way that you apply it, certainly the frequency that it is applied. Again, we encourage a long-term program instead of a one-off program. So in the first year, maybe a more frequent rejuvenation just to keep it alive. And I think, there's a lot of documented evidence out there that if you do it right, we can get really good performance out of these chemical treatments. So a lot's going to depend on the materials, and a lot's going to depend on what chemical treatment you choose, how you apply it, how often you apply it.
So the next couple of things in the chat pod are responses that people did choose the correct answer for number 3, and thank you for posting that in there. I'm certain that it probably was a user error on my part when closing out that particular poll, so I do apologize for that, and I'm glad to hear that a lot of people did get the correct answer. The next question that we had for you, Dave, is that you responded earlier to the shingle question and said, it is unlikely that the asphalt would reactivate. Is there any case where wrap material asphalt reactivates, and does the asphalt content affect gradation design?
Okay, yeah, good question. Generally, if you're using the old wrap from your distressed paved road, it's probably not going to reactivate. The problem arises if you're taking wrap off of a pile, or if the road that you're going to recycle has a lot of fresh asphalt in it. So if you've got patch material or you've got cold patch, then that material can stick together on a hot day and create a lump that could create a problem with maintenance. So generally what we say, if it's really old asphalt from the road, it's been down there for years and years and years, it's very unlikely that it's going to reactivate. But the guide does cover some simple tests that you can do to check whether it's likely to be a problem. And one of those is just putting wrap in the oven at your typical maximum temperatures and seeing if that clumps together on its own. So there is some guidance in the guide on that. In terms of your question, does the asphalt content affect the gradation design? Generally, no. We would just suggest that you take that crushed material, include it in your gradation, and not worry about the asphalt content unless it is very fresh patch material or cold patch material that you're going to be putting into them. Then you need to take a little bit more care in your decision to use that.
And we do have one final question before I move us back over to our webinar and close out for the day, and that is, are there environmental effects from milled asphalt chemical leaching, for example, water quality?
No, to the best of our knowledge, no. There is quite a lot of research on that that basically that's covered that information. The asphalt itself does not have any leachates in there that are likely to cause a problem.
Okay, perfect. Thank you guys so much. I appreciate you taking the time to present today as well as answer all of the questions. It does look like we might have one additional question coming in, so I am going to close out the webinar, and then if that question comes through, we'll ask that before we do finalize it. So right now, in this webinar, you guys have learned to identify poorly performing paved roads that are candidates for conversion to an unpaved surface, to compare maintenance and surfacing options to make the best decision for your agency, and to convert a distressed paved road to an engineered unpaved road. Again, I will remind you that the previous webinar that Laura and Dave did for us on the NCHRP project, I did post that webinar over in the left-hand side in the chat pod. In case you'd like to take a look at that. It is listed on our archived webinars page from 2017. We do have an upcoming webinars. We have one scheduled for March 25th on effective traffic safety messaging, and as always, as I mentioned, we have that listing of all of our previous archived webinars. We will be having our Safety Summit number 3 this September. 29th through October 1st in Kansas City, Missouri, and we would love to have you all attend. You can find out more information on our website, and we would also love for you to be following us on Facebook and LinkedIn as well to get more information about the summit as well as all of the rest of our great stuff we have going on. And I am going to head over to that question in the chat pod real quick before we do sign off, but as always, right on this final page are email addresses for both Dave and Laura in case you do have final questions outside of this last one that you'd like to have them answer. So the very last question that came in is, there have been several comments today on the need for skilled operators in relationship to unpaved roads and snow removal. How are you addressing the issue of adequate training for operators?
Yeah, I can jump in on that one. I think your best resource out there is the local technical assistance programs. A lot of states have got very good programs on that, and training operations. You can also deal with the equipment suppliers. I know Caterpillar and John Deere have training courses for certainly for grader operators. You know, they'd be willing to help you with that if you have one of their pieces of equipment. So I'd encourage you to go in that area, but certainly get in contact with your local technical assistance program. There's certainly a very good program in Montana. Most states have them, and you should be able to get some training assistance there.
Perfect. So I do want to thank Dave and Laura one more time for taking their time today to present to us. I think we had some great discussions, and as soon as we do have the final unpaving guide available, we will make sure that we blast out an email with that link to everyone. And again, the recording of this webinar will be available starting next week. So thank you, Dave and Laura, and everyone have a great afternoon.
Thank you.
Thank you, Jamie and Dave.